Okay, so now the second part, after we've done already all our basic counting principles, figure out how many possible outcomes. Now, sometimes there are going to be certain situations where, let's say, instead of we're picking from a large group, we're only picking like 5 people or something like that. Okay, what we're going to have to look into is whether it's permutation or combination. So we're going to start with permutation. Permutation is an ordered arrangement of items that occur when no item is used more than once, so there's no repetition, and the order of arrangements makes a different outcome. So the big thing to remember with permutation is order matters. So NPR, you've seen the NCR before, right? That's going to be combinations that we deal with in the next set of problems. But permutation is when the order does matter, all right? That usually happens when we have different roles, okay? Or different positions. So the way you could find this in your button, it's the same as what we did with the NCR in 10.5. But when you go, you're going to do math, scroll over to probability, and then you're going to see the second option, NPR. All right? Depending on what type of calculator you have, you may have to type the N first before you click this, or you may be able to click this and then you have the little boxes where you can just fill it in. Now, let's see why this is permutation, okay? You and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. In how many ways can those spots be filled? So we have different roles to fill, right? So since we have different roles to fill, okay, let's say we pick the same 3 people. If I switch up what position they have, it is a different outcome. So that means that order matters if we have different positions like this. So it's permutation because of that. Now, it is you and 19 of your friends. So in total, there are 20 people to choose from. You have the possibility to be selected for any one of these positions. And then how many positions are we filling? 3. So 20p3. And we're going to get, when we do this in our calculator, 6,840 ways that we can fill those positions. Oh my god, it's driving me nuts. Now I know there's a little formula there, but we do not have to worry about that because our calculator can do it all for us. Alright. Example 5. You need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the book, assuming that the order of the books makes a difference to you? So we literally said order matters. So we know it's going to be permutation. Now, when you think about this, right, this one is a little tricky, but this can happen. So we have 7 total books, right? And how many are we arranging? Technically, we are arranging all 7 of them. Okay, your N and your R can be the same, just like with combinations when we did binomial expansion. But your R can never be bigger than it. So 7p7. And then when we do that in our calculator, we will get 5,040 ways that we could rearrange all of this. Now, combination is different, okay? Combination is that NCR, but it's where the items are selected from the same group and no item is used more than once. So here, order doesn't matter, okay? So permutation would be if we're like trying to figure out first, second, and third place because they are different positions you could come in. CEO, operating manager, all that stuff, there are different roles. So permutation because order matters. But here, let's say I wanted to pick 3 students to get bonus points. The order doesn't matter. It doesn't make a new possible outcome if I switch the order, the same 5 people getting bonus points, right? So that's where combination comes into play. Okay, because when order matters, permutation, you're going to get larger answers. Combination, you won't. So, for example 6, it is not necessary to solve the problem. We are just trying to figure out if it is permutation or combination. So, 6 students are running for student government, president, vice president, and treasurer. The student with the greatest number of votes becomes president, second highest becomes vice president, and student gets the third largest, gets treasurer. How many different outcomes are possible for the 3 positions? Since they are different positions, it is permutation. Let's look at B. 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed with 6 people? If we're just making a committee, it does not matter the order in which I select these people. They're still going to be on the same committee in the same role. So order does not matter. It is combination. Now, Baskin-Robbins offers 31 different flavors of ice cream. One of its items is a bowl of consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? Well, even though some people are specifically like, no, this flavor has to be on the bottom, what? Don't get weird, all right? At the end of the day, the order does not matter in which they scoop the ice cream onto the thing. So this is combination. Okay? If the order matters, we have different roles, first, second, or third place, we are going to be doing permutation. If it doesn't, we're just picking people to go to be on a committee or to go on a field trip or something like that. It is combination, okay? All right. So now combination is how we do it. It's just the NCR, okay? We saw this in 10.5 as well. So if you go math, scroll over to probability, and you pick the third selection, NCR, you will have this. You don't have to worry about the formula, okay? A 3-person committee is needed to study ways of improving public transportation. How many committees would be formed from 8 people on a board of supervisors? So we have 8 people to select from, and we're only selecting 3 people. And we're just picking them for a committee, right? It's not like they have different roles within the committee. It's just they're on the committee. So it's going to be combination. So 8C3, and when I do that, I will get 56 different committees that we can have. Remember, all the problems that pop up on Edpuzzle we'll go over next class. Now our last problem for the day. In poker, a person is dealt 5 cards from a standard 52-card deck. The order in which you are dealt the 5-card deck does not matter. So they said order doesn't matter. So it has to be combination. Right? Combo. How many different 5-card poker hands are possible? So we have 52 cards in total to choose from, just one deck, and we are selecting 5 cards. So 52C5, and when we do that, we will get, big number, 2,598,000, I think that's a 9, 960 possible hands. Let me double check real quick. I don't know why that just seems really large, but I think that is true. Yep, 2,598,960 different poker hands. Okay, so a lot of different combinations we could have with just one deck. All right, and then for you to get like a perfect flush, then we'd have to figure out how many decks are a perfect flush like that. All right, I hope that last problem that you just had pop up on your screen went well, and we will go over everything next class. All right, have a good one.